The first dream of TMT was a physics colloquium by Jerry Nelson, who was the project scientist for Keck, an extremely smart guy. One of the attendees of that colloquium was Tom Tombrello, who was at that point, I think he was the division chair. And Tom got really enthused. And I don't know if Steve Cohen was there. He might have been, but Tom got Steve Cohen enthused. And the net result was that through this very simple 1-hour talk, the whole top of Caltech was buzzing. And they were at least one of them was at this colloquium, and they thought this was great. And so this is the kind of a place, this is the only place I know where this could have happened, that it's small enough that that word could have propagated up so quickly and that people would have said, well, $300 million. Now, admittedly, that's not the price now, but at that time, that was the quoted number. They would have said, okay, 300, maybe he's off a little bit. But still, that's a lot of money, and yet they said, okay, let's try. Where else would somebody do that? That's what makes Caltech special. I've been on the Science Advisory Committee. The job of the Science Advisory Committee is to watch over the project and make those decisions where it's a scientific judgment of whether A is better than B. And as we move along in this project, there are bound to be situations where the financial realities and the desires collide. Astronomers always want better, 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 and better, better, better costs more, 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 and people have to figure out where that balance is. And only people who have been involved in something like this before fully appreciate the necessity of this. But it's also interesting to think of the major efforts that we are making in this project to make sure that the partners with less experience are getting a technical transfer and are bringing themselves up, and that by the time this telescope actually opens, they will be hopefully fully capable of using it, and they'll have a much stronger community of scientists than they do now. It's new in astronomy, but in high-energy physics, CERN is the major example. The whole world goes to CERN because it's such an expensive undertaking that no one nation could possibly do it. Until this phase of astronomy, smaller groups could manage to find the resources. Keck was built by Caltech and UC and NASA as the partners, but this is a scale which is just beyond that. It's not possible anymore. I think what I would love to see is the center of Andromeda. The spatial resolution with adaptive optics of the 30-meter telescope will be much better than Hubble. And most people think the Hubble images are beautiful, but these will be even better. We're not going to abandon Keck when this thing comes up. Keck will be very important, but one new role that it will have, which it doesn't have now, is to find interesting objects for the 30-meter, to start the programs and find the samples that would then move over to this much larger telescope. And in order to fulfill that role effectively, they have to be in the same hemisphere, and the fact that they're on the same site makes it even better. Mauna Kea. Mauna Kea is wonderful because a lot of reasons. First of all, it's an island with a big mountain next to an ocean. And so the air blows over the ocean. The ocean is fairly flat, constant temperature, and the first piece of land it hits is Mauna Kea. So the air is very stable. That's very important because it produces good seeing, which is the size of a point source. If the point source jitters around too much and it's big, the capabilities of the telescope are diminished. So that's great. Next point is, because it's an island in the middle of a big ocean and there are drought problems on parts of that island, it's never going to be fully built up the way the area below Mount Wilson, which is now Los Angeles, would be. And so we don't have to worry that in 50 or 100 years we're going to be surrounded by city lights. And in fact, the government of the island of Hawaii has passed light pollution ordinances, which they enforce, and that's very good. The next point is Mauna Kea is very high and it's very cold. And the cold is great because it means that the thermal emission from the atmosphere is cut down, and observations at infrared wavelengths are much better. And the height is important because it keeps the cloud deck. The cloud deck is often well below the summit, and the summit just sticks up like a little point. And so the weather is better, and there's less precipitable water vapor, and that produces better atmospheric conditions for observing. So Mauna Kea is a truly great site. At Keck now, more than 50% of the nights are observed from California. We have about 15 remote observing stations at several. There's 2 at Caltech. There's several UC campuses. There's 1 at Yale. There are 1 or 2 in Australia. We have partnership with Australia. And so people don't go to Hawaii anymore. And that's really nice because then the students can participate. And you can send your student to Hawaii so they'll see what's going on once or twice. And you can be back in Pasadena and talk to them, and everything is great. The TMT is going to be even better because we're going to have such a powerful telescope that the chunk of time, the minimum quantum of telescope time is going to be 2 hours. It'll make it much more flexible. And all the instruments will be hot at the same time. So you can very quickly change the program, change the instrument, and the goal is flexibility. 5 minutes goal to change instruments. Having spent so much time on this project, that I would love to see it completed. I would love to go up there and watch someone observe and sit in the control room and just watch everything whirl around and know that it works and feel like I've built something good. But I'm too old to actually use it. And I'm too busy to keep up for the next 10 years. And so I think it's going to be the job of my students to take advantage of it. It is a great pleasure and a source of considerable pride to be able to walk around both Palomar and Keck and look at things and say, I helped to build that. That's a really good feeling, and it'll be nice to have that feeling for the TMT too.